Hello everyone, and then welcome to another tutorial video. Okay, so in this video we'll be talking about effective resistances and total resistances. Okay, we'll be solving some sample tutorial questions so that it will broaden your scope, okay, your understanding about the entire topic. Okay, so before I proceed, kindly subscribe. Okay, kindly subscribe so that you get access to all our videos, and then by clicking on the bell icon. Okay, kindly like, share, and then let me know your comments in the comment section below. Okay, so let's look at the first example. Okay, so we have example 1. Maybe you have a circuit like this, okay, with these resistors, right? Okay, and then we have that. Okay, right, then we have this one too. Okay, right, so note that all these resistors are what, in 3 ohms. Okay, all these resistors are in 3 ohms, so we have to find the effective resistances, okay, or the effective resistance. Okay, so now one thing you need to know is that this is 3 ohm, 3 ohm, 3 ohm, 3 ohm, 3 ohm, and what, 3 ohm. Okay, so you will notice that this 3 ohm, okay, this one is in what, series with this one, okay, because the same current will pass through. Okay, so we have what, 3, okay, plus 3, okay, and that will give us what, 6 ohm. Now this part is gone. Okay, so now after getting the 6 ohm, we will notice that this resistor will be in what, parallel with that 6 ohm. Okay, that's when we add this and that. Okay, so that's when you traverse. Okay, when you traverse, you only come across the 2 resistors. Okay, so we have what, we have the 3 ohm. Okay, we have the 3 ohm, right, multiplying by this 6 ohm, okay, divided by what, the 3 plus what, 6. Okay, so that's where we have what, when you do this calculation, you get what, 2 ohm. Okay, right, now from here the circuit has been reduced to this form. Okay, you have something like this. Okay, yes, so we have what, 3 over here, 3 ohm, 3 ohm. Now we have what, 2 ohm over here, and then we have what, 3 ohm over here. So now again, this will be in what, series with this one. Okay, so we have what, 3 plus 2. Okay, that will give us what, 5 ohm. Now here is now 5 ohm. Okay, this will give us 5 ohm. Okay, this will give us 5 ohms. Okay, so now since 3 and 2 gave us 5 ohms because they were in what, series, that 5 ohm will be in what, parallel with this one. Okay, so that means when you traverse, you won't come across any other elements aside the 2. Okay, so aside the 3 ohm and the 5 ohm, so we have what, the 5 ohm, and then what, 3 ohm, then we have 5 plus what, 3. Okay, and that will give us what, 15 on what, 8. Okay, yes, this will give us 5 3 what, 15, and then what, 5 plus 3 is what, 8. Yes, you are right, ohms. Now since we now have this 3 ohm, okay, so it means that we have our circuit reduced to this form. Okay, okay, there we go. Okay, and then what, 15 on what, 8 ohms, right? So all you have to do is that just add this and this one. Okay, so this 3 ohm and then 15 on 8 ohm. Again, for question 1, okay, we can use the delta star approach, okay, to get our answer. Okay, so instead of going by the normal total resistance calculation, okay, you can also employ the the delta star calculation. Okay, so let's see how that could be done. Okay, so we have this. Okay, there's a circuit. Okay, so we want to just reduce this form. Okay, you could see that there's a node, another node, another node, and then what, another node. Okay, so all we are trying to do is just reduce the node. Okay, now, and then for delta star calculation, whenever you meet resistors which are the same, okay, all you have to do is just multiply it by 3. Okay, multiply one of the resistors by 3. That's if you are converting from one delta to star. Okay, so this is how it works. So delta, okay, is equal to 3 times star resistor. Okay, delta is equal to 3 times star resistor. So we are trying to convert this, okay, into a form like this. Okay, since we have something like this, we could just convert this, okay, to something like this. It's either we convert, listen to this part very carefully, it's either we convert this delta, okay, into a star, or we convert this star, okay, into a delta. Okay, once you go through my video on delta star transformation, you will get to understand what I mean by this. Okay, so in case you haven't watched that, kindly do before you go through this. Okay, then you understand. In case you haven't, you can also follow, you might understand. Okay, so this is a delta arrangement. Okay, this is a delta arrangement because we have 3 resistors which are either in series or what, parallel, and then we have another one over here. Okay, okay, this portion is this one, and then this portion is this one. Okay, that's why you have 3 3 and what, 3. Okay, and then you have what, 3 3 3, right? So is either we convert this into delta or we convert this into what, star. Okay, but let's convert this one into delta so that we could move faster. Okay, we want to move faster, so let's just clear this one. Okay, and then use this formula. Okay, since we know that converting star to delta is what, delta is equal to 3 times the resistor for the what, star, and then we know that once all the resistors have the same value, we can then employ what, this formula. Okay, so we have delta is equal to what, 3 times what, 2, which is what, 6 ohms, right? So it means that you will be representing this, okay, the entire of this with a certain 6 ohm, okay, resistor. So this is how the circuit will look like. Okay, then we have this, okay, this, right, and then that. Okay, so this is what, 3 ohm, but this is what, 6 ohm. Okay, 6 ohm, and then what, 6 ohm, this is what, 3 ohm, right? So all we have to do is just do a simple calculation. Okay, you could notice that 6 ohm and 3 ohm are what, in parallel, because when you traverse through it, you won't come across any other what, element. So you have what, 6 by 3 on what, 6 plus 3, which will give us what. Okay, so this will give us what, this is in parallel, so we have 6 by 3, and then what, 6 plus 2, this will give us what, 2 ohms. Now we are done with this portion. Okay, so let's break this one down. So we will get something like this. Okay, something like this. This is already 3 ohm. This is what, this 3 ohm. We didn't write this part, so 3 ohm. Okay, so it was 3 ohm, and then we have this one. Okay, this is 6 ohm. Okay, right, so we have this to be 6. Okay, and then have this part. Okay, okay, yes, and then this one will be what, 2 ohm, right? Now we can further simplify this. We could notice that this 6 ohm and this 2 ohm are in what, Yes, your guess was right. They are in series. So 6, have what? 6 plus what? 2 give us what? 8 ohms, right? Now, this is now what? 8 ohms. The whole of this portion is what? 8 ohms. So it could be further simplified as what? This 3, this 3. So instead of drawing this resistor this way, you could just represent it like this, okay? Then we have our what? Our 8 ohm, okay? 8, 6, and a what? 3, right? Now, you will also notice that the entire of this one is what? Parallel, okay? So you have what? 6 by what? 8 on what? 6 plus 8. And this will give us what? Yes, 24 on what? 7, okay? 24 on 7 ohm, right? Now, 24 on 7 ohm. So now, the entire of this one is in what? Parallel, and then we had the answer to be what? 27 on what? 24 on what? 7 ohm. Now, means that this part, this portion, will be what? 24 on what? 7, okay? Now, from here, let me draw it very well. Okay, so from here, we could notice that the 3 and then 24 on 7 ohm is also in what? Parallel. So, you then work that 1, 2 out. So, you have 24, 7 by what? 3 divided by 24 by what? 7 plus 3, okay? And then you end up with what? 8 on what? 5, okay? Ohms. Now, so from here, you could notice that we further simplified this, okay? We further simplified that, okay? So we have what? The 3 and then what? 8 on 5 will be in what? Series, okay? So it will be reduced to this form, okay? We have this, okay? This 3 ohm and this what? 8 on 5 ohms, okay? So this will be what? 8 on 5 plus what? 3, okay? So you might get an answer close to 5 ohm, okay? Approximately 5 ohm, okay? Which is also equal to our first formula, the first approach we used, okay? Very, very similar to the first approach, okay? Hope you were able to understand this part, okay? So let's move on to the next example, okay? So this, we use the delta star, okay? First, we converted the star into delta, and then we came up with this, okay? We calculated for parallel circuit. We had this, represented it by this, okay? Then from this, right? We had that, okay? From 6 and 2, okay? This 6 and 2, we had this, okay? Then we further simplified it to get this, and then further simplified it, okay, to have this, and then we calculated for this one, okay? And then we have our final answer to be approximately 5, okay? Might end up having 4.6 something or so, okay? So you can just run it to 5 ohms or maybe 4.7 or so, okay? Right, so let's move on to the next example. Well, alright, so we have another example, okay? So we have this circuit, we have to find the total what? Resistance or effective resistance, okay? Now, let's start from a point to the other point, okay? So that we will just narrow down our answer, okay? We could either start from here, okay? Or start from here. So either way, you get the same answer, okay? So maybe let's start from where? You could either choose to start from here or start from there, okay? So maybe let's start from here, okay? So let's start from the left hand side. So from here you can notice that the 16 and 8 are in what? Parallel, okay? So you have what? 16 by 8, okay? On what? 16 plus 8, okay? And this will give us what? 16 on what? 3, okay? Sorry, we have 16 on 3 what? Ohms, right? Now, the entire of this one is what? 16 on 3 ohm, okay? Now, so we could realize that this has been reduced, okay, to this form, okay, has been reduced. So we could just simplify this by identifying that this is not an important circuit, okay, it's like a short circuit. In case you remember short and what open circuits, you could realize that that was what a short circuit, okay, has no resistance on it, okay, right? So this 16 on what 13, okay, could be represented by this resistor, okay, 16 on 3, sorry, okay, 16 on 3 could be represented by that, right? So from here you could notice that the 16 on 3 ohm and then 4 ohm are in what? Yes, you might be right, they are both in what? Series. So we just add them. So we have what? 16 on 3 plus what? 4, and this will give us what? 28 on what? 3 ohm, right? Now we have the entire of this side to what? 28 by what? 28 on what? 3 ohm. Okay, so you could just change this, okay, just change this, represent this by what? A single resistor, and then represent that portion to what? 28 on what? 3 ohm. Now, so from here you could notice that this one and this one is also in what? Parallel. So let's find that, okay? So you have what? 32. So you have what? 32, okay, by 16, okay, all on what? 32 plus 16, which will give us what? 32 on what? 3 ohm, okay. Now since we know that this side is 32 on what? 3 ohm, it means that we could just simplify this form, okay. It means that the whole of this will be in series with this value, okay, the whole of this portion, the whole of this portion will be in series with the 28 on 3, okay. So we have what? This will further simplify to give us what? 28 on what? 3 plus 32 on what? 3, and this will give us what? 20 ohms, okay. So we could just do the same thing either way, okay. So let's do the same calculation starting from the bottom, okay. Let me clear this one, okay. All right, so now the same example, you have that, okay, that, and then you have this, then you have that, okay. So you have this, and then we have what? This 16, this is 32, this is 4 ohms, this 8 ohms, this 16 ohms, right? Now let's start from here, okay. Instead of starting from here, we are starting from here. So we have this to be in what? Parallel, okay. So you have what? 32 by 16, okay, and what? 32 plus 16, and this will give us what? 32 on what? 3 ohm, okay. Now this will also be in series with the 4 ohm, okay. So we have 32 by 3 plus 4, okay, and that will give us what? 44 on what? 3 ohms. Now, so from here you will notice that this one is also in what? Yes, it's also in parallel. So you have what? 16 by what? 8 on what? 16 plus 8, okay, and that will give us what? 16 on what? 3 ohm. After that you just add these two values, okay, because that will be in series with that resistor, okay. So you have 16 on 3 plus 44 on 3. Okay, this will give us what? 20 ohms. Okay, I hope you understood this portion of the question and then solution. Okay, kindly subscribe. Okay, subscribe and then hit on the bell icon so that you don't miss out on any uploaded video. Okay, like, comment and share. So I'll see you in the next video. Bye bye.